Right, because I forgot to record last time, so I had to do it again. Right, so any questions you have, feel free to stick it in the chat. That will be at the bottom of it. And you can write any questions. If you want to introduce yourself, if you don't know anyone else, feel free to do that. Tell a little bit about yourself, and yeah, we can just go from there. I know there's going to be a few people joining later, and hopefully you guys, I'm sure some of you know what I'm going to say, some of the stuff I'm going to say. If you think of any questions afterwards, feel free to email me. I'll answer all your questions. So that's cool. So where is the share screen button? Oh, here we go. Okay. Right.
Volume.
Volume, yeah.
I'm using, so I'm using something called Canva. Whoops. You're seeing all my slides. Okay, permaculture, a regenerative mindset.
A good sign on there.
Can you see that, guys? Yeah?
You
Yeah.
Can I have a thumbs up if
Yeah.
you can see it, please?
no,
No?
one all black.
Oh.
Yeah.
Tony, can you stick your hat? Yeah, is that good?
Yeah, I can see it.
Yeah? Okay, cool. So, thank you, Tony.
It's going black.
Permaculture, sorry, guys, can you put yourselves on mute, please? Which is, it's down the bottom, just because I'm getting a little bit of interference. Thank you. So permaculture, a regenerative mindset. The reason I decided to call it a regenerative mindset is because creating an ecosystem requires, I believe, a change in mindset. We're all taught about this kind of linear way of life, and that's just not how life works. Life's a cyclical system, you know, and we can see this through the planets that revolve around us, night and day, the seasons, etc. So my experience is when I changed my mindset, it actually changed the way I thought about the world. And it meant that even when things seem hopeless, there's always a solution, you know, because things always come back around. It's like trends, right? And this little graphic I have here, this is just kind of a snippet into what permaculture is about. I mean, obviously permaculture is about growing food, but it's more than that. It's about a set of principles that we can adapt and apply to all sorts of different parts of life. And whether that's society or the economy, when we think with a regenerative mindset, we can actually create really healthy, abundant systems. And that's really important to remember because, I mean, look at where we are now, the world as it is now, there's a lot of uncertainty. Things are changing really rapidly. So it's really helpful to have a set of principles, design principles, that give us a framework that we can work within. And we can still express our individuality, but this framework is really important to allow us to be able to grow, expand, and evolve. So soil regeneration. Why soil regeneration? I'm sure some of you know we have really bad soils around the world. Our agricultural soils have been poisoned, toxified. They lack most of the nutrients or most of the micronutrients that we need for plants to be healthy. And, you know, there's lots of kind of research around the nutritional content of food, but it's estimated that between 30 and 80% less nutritious than it was pre-World War II. So obviously this is a big component of a lot of the chronic diseases that we see now, you know, and that goes from everything from, you know, autoimmune diseases to things like cancer, etc., along with things like glyphosate that get sprayed on the food. That doesn't just poison the plants, it poisons the land, it gets into the water tables, eventually gets into the ocean, it acidifies the oceans. And that's one of the biggest causes of pollution on the planet. So it's really important that we kind of separate natural climate variability as well with pollution. You know, they're two separate things. And the thing that we have most control of, I believe, is growing food. You know, we can certainly provide our own energy, but growing food is something that's not only achievable, even on a balcony, but it's also something that brings a community together, and we can really create a lot of diversity in a very small space. And everything begins with soil. Everything on the land, all life relies on the soil. And this connection between the soil, the sun, the plants, all the microbiology in the soil is how we can achieve optimum health for ourselves. So this is a little video that my friend Giuliano put together for us. If it works, I hope it does, because it's quite cool, but it doesn't look like it's going to. This is a problem with technology. Here we go. Okay. Right, we're going to have to scrap that because it's, sorry, Giuliano. But it's a really good video. I mean, I can send it to you guys, but it's just about how complex life is in the soil. And that actually it's, although nature is really good at repairing itself, it's up to us to bring back life into the soil. And it's actually easier than a lot of people think. It's really about understanding the interconnected web of life. That's the essential thing. Once we start to do that, there are many things that we can do to actually change how we grow our food and what grows in our food, or what grows in our soil, sorry. So this is a little picture of compost that me, my friends Giuliano and George did last year, I think it was. And it was thermophilic composting, which is hot composting. I'm sure some of you have heard of this. This is really good at getting a lot of diverse bacteria going, and you can achieve it within about a month. You can then let this soil rest, and that will allow like the fungal component to start getting into the compost. We actually tested this compost with a soil biology lab down in Dorset, and it was our first attempt, but the numbers of protozoa nematodes, bacteria and fungi we had in the soil, it really surprised us. And the reason I'm sharing this is because it was our first go at doing it, you know, so like anyone can create this. It's quite amazing. Topsoil and subsoil. These are really important components of the growing medium. We tend to find these underneath kind of the top part of the soil. So the top part of the soil in healthy soil will be organic matter. And this topsoil and subsoil comes in three forms mainly: clay, silt and sand. They vary in particle size. And they're mainly made of silicates. And these silicates are related to silicon. And everyone knows what silicon is used for. Silicon is used for microchips, etc. So this topsoil and subsoil actually has the ability to hold electrical charge. And this is really important to remember, because electrical charge passes information, just like in microchips. It's actually called CEC, which is cation exchange capacity. And that's the ability for the clay, soil, salt, sand and silt to hold electrons. I won't get into more of the science at the moment, but the clay and the silt and the sand also has a mineral component to it. Clay actually has the highest mineral content, and it also has the highest ability to exchange cations. So that's really important to remember. Most of us around this area, around London and Essex, will be sitting on clay. This doesn't necessarily mean that we can't change the ability for these electrons to pass through the soil. But I've called this the stage because this is something that you can't change unless you bring in loads of clay or sand or silt. But it provides that base layer for the next part of the kind of soil biome. So the organic matter is where all the life happens. This is where decomposition happens. And this is where most of the microorganisms will live. So organic matter can be anything. In a forest, we find it's fallen leaves and other stuff that's kind of died down. And what happens is over time that rots down, decomposes. Some of this will turn into humic compounds. So this can be humic acid or fulvic acid. And this is what all the microbiology feeds on. What it also does is it creates a buffer against temperature change and moisture change. So in our agricultural fields, we see this kind of swing between drought and flood. And if any of you have driven past farmer fields when it's rained heavily, you'll see it's flooded. The reason for that is compaction. Okay, so that's another important thing about organic matter is if you leave the organic matter to rot down, all of that will be pulled into the soil and it will actually go into the clay, the silt or the sand. That means that actually plant roots can penetrate better, it can hold more energy, and it's also an environment for these biological, chemical and electrical processes to occur. So the soil food web, I called this the cast. I'm just kind of using these analogies so it's a bit easier to understand. But you can use any that it's easier for you to understand. So as some of you know, you've got the fungi and the bacteria, you've got protozoa, nematodes, you've got your microarthropods, which are, you know, sometimes like a couple millimeters, or they can be microscopic. Then you have your arthropods, like your spiders and your woodlice, and then your earthworms and your birds. All of these are essential. And obviously each of them will have lots of different variations. So it was thought at one time that nematodes were really bad. But but you have several different types of nematodes. You have fungal nematodes, you have root feeding nematodes, you have predatory nematodes, etc. And just like in any ecosystem, the soil is full of life. The more biodiversity, the healthier it is. The more biodiversity there is, the less chance there is of pathogens and viruses from taking hold of the soil. Now, in our industrial agricultural system, you might have a bit of bacteria and some worms, but that's about it. So it's impossible for healthy food to grow in these industrial agricultural settings where we have fertilizers, etc. And just a kind of an offshoot of this, when fungicides and insecticides and fertilizers are sprayed on plants, what it actually does is it inhibits these plants from producing amino acids. And they're obviously, as some of you may know, these are the essential building blocks of life. So the plants can't grow healthy. All they're relying on is the fertilizers that are sprayed on the plants. So essentially they become drug addicts. So plants, the set. I've called this the set because you can change the set depending on where you are. And plants are essential. This is obviously just a theory, but it's got a lot of research and evidence to back it up. But they believe that soil actually started to come about from the integration of things like lichens and rock, or fungi and rock, and the fungi would actually break the rock down over a long geological time span. This would then turn into soil, essentially. So the plants are the connection between the sun and the earth. They are the best energy producing engine anywhere on the planet. And through this process of photosynthesis, the plants then gain the energy they need to turn this into carbohydrates. This then gets exchanged in the soil with the microbiology. So we need all these components. We need the minerals in the soil, we need the biology, and we need the plants. If the fields are just lying fallow, there is no photosynthesis happening. So life cannot occur, essentially. Yes, so next slide. The sun, I called it the right. I mean, as I said, these analogies might be not understandable to you, but so the sun is everything. I mean, it provides us with all the energy we need. All energy, whether it's oil, gas, solar, wind, it's all created by the sun. So that without the sun, we have no photosynthesis, we have no life. And the really amazing and clever thing is this electrical energy from the sun gets transformed by the plants into biological and chemical energy, and back again into electrical energy in the soil. And this energy can actually be measured in millivolts. The term for this is EH. Another term would be called redox. Now, the reason this is important is because up until very recently, maybe up until the 90s, it was just thought that pH was the defining factor of what could grow in what soil. But a very accomplished man called Dr. Olivier Husson, he did a lot of research into, well, let's kind of go back a little bit. He studied physics, biology, and chemistry. Now, up until kind of the 90s, they measured soil through chemistry. What he's done is he's combined these sciences, and he's come up with this new way of measuring the energy capacity of the soil. So it's called redox, and that's split into two. You have oxidation and reduction. So that's really important to remember. If any of you want a link to his work, just give me an email and I'm more than happy to send that to you. So testing soil. Before we know what we can grow in soil, we kind of need to know what's in our soil, okay? So to establish that, there's some simple tests that we can do, but it's quite important to remember this. I mean, when I first started growing food, I didn't test soil, I just planted stuff in there and I wondered why it was dying or the leaves were yellowing or anything like that. So there's lots of tests we can do. As I mentioned, pH, if some of you know, pH stands for power of hydrogen. So it's the amount of hydrogen that the soil can hold. And you can have tests for bacteria, for fungi, chemicals, and minerals. And we can all use these tests. Some you may have to send off to a lab if that's something you want to do. But there's some very simple tests you can do. So a pH test, that will give you an indication of what you can grow in your soil. If there's certain things that you want to grow that require a different pH, you need to remediate the soil. Okay, this is a soil jar test I did on my allotment end of last year. It's really easy, anyone can do it. All you need is a jar, a clear jar, a trowel, and you need to dig up wherever you want to grow your food. Just dig it up, fill it half up with the soil you've got, half up with water, shake it for 30 seconds to 60 seconds, put it on a flat surface and let it settle. And what you'll find is the particles will separate, and on the bottom you'll have sand, which is the biggest, they'll be the biggest grains. Then you'll have silt, then you'll have clay, and that top bit is organic matter. It takes about 48 hours for it to all settle down. Some of these beds that I tested, they have different organic matter in. What that allows me to do is understand what I need to add to each bed, depending on what I want to grow in it. Okay. Again, if any of you want a little bit of instruction on how to do this, just email me and I can send it to you. So there are also tests we can do for biology, nutrients, and electrical charge. You can send it off to a lab and the soil off to the lab, and you can get an indication of what's in the soil. You can also get nutrient tests, so you can test, you know, your nitrogen, your potassium, all the micronutrients as well. So they do tests for copper and zinc and molybdenum, and there's even instruments out there that can test the amount of millivolts in your soil. They're quite expensive though. So industrial agriculture uses nitrogen, potassium, and phosphate. Although these are the main nutrients that plants need, we also need the micronutrients as well. You can do your own research, but a lot of these micronutrients are available in the soil, but they're insoluble. That basically means that plant roots can't uptake them. So in order to make these nutrients soluble, we actually need the microbiology in the soil. So I've listed the macro and the micronutrients there. Some of these I'm sure you would have heard of. Some are less well known. But I'll give you an example. So cobalt, which is actually used for, it's quite crazy, but it's used for solar panels and electric cars, etc. It actually is the catalyst for producing B12. So if you haven't got cobalt in your soil, B12 cannot be produced. And many of us know that B12 is in eggs. So if those chickens aren't eating plants from soil that has cobalt in it, there'll be no B12 in the eggs. Pretty crazy, right? Now, they may supplement their diet with fortified B12, but it's really not the same. It's not going to inhibit into your system in the same way. And this goes on to this. We don't need supplements. The only reason that we have to have supplements, like our zinc, etc., is because the plants aren't getting them from the soil. So if we have a biodiverse and balanced soil, then you'll find that you won't need these supplements. And also, if you're outside growing food, you're going to get more vitamin D, which means you won't have to take vitamin D supplements as much. Okay, so why is it important to know all this? Soil health directly relates to human health. And if you want to check this out, there's a guy, some of you might have heard of him, Dr. Zach Bush. Really cool doctor. I mean, he fell into being a doctor after like doing different things, but there are a thing called mitochondria, which are in all of our cells. They're in plant cells as well. So when the electromagnetic energy of the sun hits the plants and photosynthesis occurs, those mitochondria transform that electrical energy into carbohydrates. We then eat the food, and our mitochondria and our cells transfer these carbohydrates into something called ATP. That's adenosine triphosphate. And that energy, or the ATP, it actually drives many of our cellular processes. So in a way, we're actually eating the sun's energy, which I find just completely remarkable. So yeah, I love that one. That's really cool. So we are the sun, right? And this kind of leads on from what I was talking about, redox potential. So our soils can be acidic, alkaline, they can also be neutral. They can also be reduced and oxidized. So the pH test will tell you about the acidity or alkalinity of your soil. Just a caveat to this, the pH of the soil can change in micrometers. So you may take the pH of your soil in one area and it may be, say, 7.2, and, you know, like a foot away, it might be 6.5. The important thing to remember is whenever we're looking at soil, we need a balanced soil. In permaculture or in soil science, they call it the ideal zone. And really what we want is a pH of between 6.5 and 7. That's the ideal zone for most nutrients to be available to most plants. Obviously, if you're growing fruit trees or an orchard, you need soil that's more acidic. So, and as I said before, the industrial chemically fed farming system actually oxidizes soil. So when we plow soil, what we do is we actually take oxygen out of the soil. We also rob it of carbon, and it can also lead to leaching of other chemicals that we need. So when you go into a forest, the soil is reduced. This is why you get so much life there, because there's so much energy. So reduced soil basically just means that when I mentioned about cation exchange capacity, it means that more energy is held in the soil. That means that more nutrients can be passed quicker from plant to plant through the soil. And this occurs through microbiology and also things like mycelium. So, as I just said, oxidizing soil lose energy, reduced soils gain energy. And when we're growing food, especially in the permaculture setting, what we're always trying to aim for is a reduced soil. There is a caveat to this as well. Obviously, if you're starting off on a bit of land, you might need to dig it over. Okay, because obviously you might need to take stones out, etc., and but once you've got a system established, you want to create as little disturbance as possible, because the more disturbance you create, the harder it is for nature to repair itself. And of course, we can add amendments and things like that, which will help it get to that place that we need it to be. But the less we mess with the soil, the healthier our food will be. So as I mentioned about the ideal zone, balance is everything, like in life. You burn the candle at both ends, eventually you're going to pay for it. So healthy soil is one which allows the plant roots to team with the microbiology to be able to access the nutrients and allow the right amount of water and air to penetrate into the soil. Again, compacted soils won't allow water to seep into the soil. This is why you get the floods and the droughts. If farmers looked after their fields in the correct way, or the most effective way, we wouldn't need the amount of irrigation, they wouldn't need the amount of water, because a lot of the water would be held in the soil and it would just sit there until the time that it's needed. So you can find this on the internet, but the 5 ways to good soil, this was a guy called Gabe Brown came up with this. He's in North Dakota in America, and he's got, I think it's 5,000 acres. And he's transitioned from an industrial model to a regenerative model. And he's producing just as much food, much healthier food, so he can actually sell it for more. So Armour, basically, it's what it says. We need to keep the soil covered at all times. If we don't cover the soil erodes. It loses energy, it loses oxygen, it loses carbon. If we keep the soil covered, then those plants are always photosynthesizing, so they're always bringing energy into the soil. Now, in temperate zones, obviously we're restricted to what we can grow during the periods of like winter, but you can grow things like cover crops, and there's loads out there. There's alfalfa, clover, and you grow those in the soil. They don't just keep the soil covered, but they also fix nitrogen, and that's really, really important. And no tilling or minimal disturbance. The less we disturb the soil, the more energy is going to be in there, the more life that will be in there. We're not going to damage the mycelium that can be forming, and plant and micro biodiversity. Obviously, there's a limit to how much biodiversity you can have in a space, but the more stuff you grow, the healthier the system will be. And that also applies to, if you're growing tomatoes, grow 4 or 5 types, because obviously you probably all know about blight. If one variety of tomatoes gets blight, you want to give yourself as much of a chance of actually having a yield at the end of it. And this is actually what occurred in the potato famine, is they only grew 1 type of potatoes. If they had grown more, then, it may not have ended the way it did. And continually have live plant roots in the soil. This can be covered by the Armour. So keep those things in there. When they've gone through their life cycle, you can chop them down, and that will be mulch for the next year's planting. Livestock irrigation. So this doesn't apply to everyone, but you can add manure. I mean, really all it means is that you're integrating animals into the system. And really, mainly, when it comes to growing food, what we want is their manure. I get organic manure from somewhere local. I'm sure if you do some research, you'll be able to find that. Okay, so this is me on my allotment plot. That there in my hand is a gorse plant, and they are amazing for fixing nitrogen. If you can see that little yellow ball, that's a nitrogen fixing nodule. So plants like these and legumes actually pull nitrogen from the air, they fix them in these nodules, and then they let them out over time. So I've planted these all around my trees and my fruit bushes. They need a lot of nitrogen, especially when they're young. So I've done this to provide nitrogen for it. And so the rhizosphere, this is the area around the plant root. It's where all the magic happens. It's where the exchange between the plant root, its exudates, its secretions of carbohydrates, which are sugars, they exchange these with the bacteria and the fungi. The bacteria and the fungi will go and farm the nutrients that the plant needs. The plant actually tells the microbes and the fungi, I need copper, I need zinc. They will actually go and get this and bring it back to the plant root. When these bacteria and fungi get eaten by protozoa or nematodes, the excretion of the nematodes and the bacteria's manure actually gets sucked up by the plant roots. So the plant is constantly cycling these nutrients. I mean, it's absolutely mind-blowing. So these exchanges, I mean, we only know about 1% of the life in the soil. So there's so much more to discover. But once you get these systems installed, they actually start taking care of themselves. So, I mean, I'm constantly smiling when I read things like this because I think it's just so wonderful, and it gives us a real insight about what's possible. Microbes facilitate the exchange in the soil. They determine everything from the nutrients the plants can absorb to a defense against pathogens and disease. Again, if you have a healthy microbe or a healthy soil biome, the plants become healthy. They can reach optimum health. When plants are at optimum health and they're getting all the nutrients, all the micronutrients they need, they become, their immune systems become so strong that pathogens and disease can't actually attack them. Some of you may know this, but insect or pests only go for plants that are not at optimum health, because the plant will send off a signal, a chemical signal or a biological signal, and the insect knows to go and eat it. I mean, it's such an amazing system, because it means, like, you know, you can liken it to a lion chasing after a pack of wildebeests. The lion is always going to go for the weakest wildebeest because it has to put less energy into it, right? So remediation, we can build, regenerate and restore soils that have lost their mineral and biological life balance. So whether you're growing food in soil or a container, it's important that we have the balance and the interconnectedness of the soil food web. And these, you can do these in two ways. You can add biological amendments and mineral amendments. So these are just a few. Just so you know, my next webinar will actually go into how these amendments work, and whatever your context is, I'll tell you what the amendments you can use to condition your soil. So you can add your own homemade compost. You can buy a compost, but what I suggest is you do your research and you buy from someone who actually makes really good compost. I've bought compost before and it's had plastic in it. That's not, it's not compost, is it? It's just like soil with plastic in it. IMO preps, so this stands for indigenous microorganisms. I did this last year with my friend George. I went to my local woodland. I looked for an undisturbed place, and you can actually collect the microorganisms from this healthy place, take it back and introduce it to your soil. And the reason they call it indigenous is because the microbes that you find in your area will know what is in your area, essentially. So they know what the soil profile is. This is really easy. If you want to look into, there's a guy called Chris Trump. He's been doing this for like a decade, but he studies a thing called natural Korean farming, and he's a master at it. He learned from the guy that actually invented natural Korean farming. So the next one is lab. This is Lactylus bacteria. So you can actually create this from rice and milk. You know how they separate the curds and the whey? It's that process. And the bit that you get left over with, they actually use this in pig farms to kill the pathogens. It's pretty profound stuff, and the fact that you can make it yourself is phenomenal. And then you have your mycorrhizal fungi. You can't really make this yourself, although you can get this from your IMO. You can buy it online, and it will have a number of different arbuscular mycorrhizal fungi in it. So if you need to, if your soil is very alkaline, you can add things like this and it will help it become more acidic. And then you have your plant growth hormones, so PGPR. So these are known as rhizobacteria. What these do is actually strengthen the immune system of the plants. Again, you can buy these in powder form, or you can actually cultivate your own. And then something that I use a lot is compost worms. If you have veg scraps and things like that, you can actually make your own compost bin, introduce the worms to it, and they will actually digest your kitchen scraps and turn it into what they call black gold. And then one of my favorite ones is EM, effective microbes. So this is a consortium of different microbes that you can use to kill pathogens, to make your soil healthier. You can even use it if you're adventurous and you want to build your own compost toilet. EM works by breaking down the pathogens even quicker. And ineffective microbes, you have lab, which I mentioned. You also have a thing called PNSB, which is purple non-sulfur bacteria. And that is actually produced in a worm's gut. And then you have other things like yeast that you can add, and bioceramic powder. All of these you can get online if you wish to do so. And then your mineral amendments. So a lot of the soils you can't, unless you've got the microbiology, you kind of need the minerals in there. So you can get this in different forms. And it just means that you're getting things like your carbon and your nitrogen and your copper and your zinc in these different forms. Biochar is a little bit of one that sits on the edge. That's basically wood that's been burnt to a particular stage. But what biochar does is it will hold nutrients, it holds water. And if you charge the biochar, what it essentially can do is it acts like a house for microbiology. So if you get a little bit of biochar about that big, you can stretch it out. I mean, it's phenomenal how far it can stretch out, but you're talking maybe, like 150 square meters, something like that. It's quite phenomenal. And then you have your wood chips. So that's a really good source for fungi, because obviously fungi feed off decomposing wood. That's why you get a lot of fungi in woodland and forests. Hay is a really easy attainable resource, and that's full of carbon. And then obviously the leaves as well. There are caveats to this, because there's certain leaves that are better for decomposing than others. And then, as I mentioned before, your veg and your fruit scraps, they're easy achievable. Just be careful that if you're using non-organic stuff, it could have pesticide residues on there. Then there's seaweed or kelp. Kelp's not that easy to get in this country, but you can get a thing called Hebridean seaweed. That's got all your trace nutrients in it. There's a place that does organic one. I've got it. It's really, really good. But that's amazing. So again, the likelihood is your soil probably won't have those micronutrients in abundance. So adding things like seaweed is a really good way to go. And then ocean water, that has all the minerals you need, and rock dust. So that's kind of the end of the presentation. I hope that's given you a little bit of an insight into what soil regeneration, the basics of it. And the reason I kind of did it this way was I wanted to give you more information, but there's quite a lot of information, and I kind of want to give you the foundations of what soil is and the problems we're experiencing now with it. So I'll stop sharing my screen. If any of you have any questions, feel free to ask me. I did have 2 questions actually from Pauline. I don't know whether she's here, but I'll answer them now. Pauline asked about...
Hello, John.
Oh, hello,
Yeah.
Pauline. How you doing? You okay? Pauline, you
Okay,
asked
thank
about-
you.
Good. You asked about leaving your soil fallow. I don't know whether you heard what I said before, but if you leave your soil fallow, or if you leave it basically uncovered, it will lose energy, it will lose carbon, it will lose oxygen. So the best thing to do is plant something in it, whatever it is. I mean, do you have an idea of, like, what's the context of it exactly?
Well, I'm just learning about all this, and I remember when I was in school in geography lessons, they always said that you had to plant 1 year, then plant a second year, but in the 3rd year, leave it fallow. So I was just wondering, in the context of permaculture, whether that's still the case. But it's interesting what you say about always leaving it covered, and you could use clover as well, which is very healthy.
Yeah, definitely. I mean, that's still, there's always caveats to these things. It depends on what you're growing in it. So for instance, if you're growing potatoes, you can't continue to grow potatoes year on year, just because things like blight can set in. But if you are doing a crop rotation, there's nothing to stop you from planting different crops in that same space. One of the reasons we kind of do crop rotation, apart from potential disease, is that certain plants will take certain nutrients out of the soil. That means that if you're going to plant something that requires that nutrient that's been taken out by the previous plant, it's not going to be able to get it. But this is why soil testing is quite important, because it's not just about understanding what your soil needs, it's just a process that is really beneficial to go through. Because I think in order to grow healthy, well, I know in order to grow healthy food, you have to have a context, you have to have a foundation down before you start that. there are plants that you can get that will help pull up nutrients from the subsoil. Obviously, if you're growing in a raised bed and it's just compost, that won't work. But there are certain things like comfrey, which are deep rooters, rhubarb, which is the deep rooter, and that will help pull those nutrients that are in the subsoil up to the top. But you can also, if you have a healthy soil biome, there's a woman called Dr. Elaine Ingham, and her philosophy is, if your soil biome is healthy enough, you can grow whatever you want in that soil year on year. Obviously, the caveat is things like potatoes.
Oh, okay.
Yeah. So I would say do a bit of think about what you want to grow. You know, for this year, if you know, I don't know how big your space is you want to grow in, but if you grow a number of plants in that space, you're going to have a biodiverse system, which will start setting you up. Is that okay?
Okay. Yeah, and when you harvest the plants, do you leave the root? Is it best to leave the root in the soil and just leave it there, or should I pull the root out as well?
Okay, so you
Say like with a tomato plant.
Yeah, sure. Well, you can leave the root in there. I mean, really the only beneficial, as far as I know, but obviously these things change because more research comes out kind of week on week. The thing that you need to definitely leave in there is if you're growing nitrogen fixing plants like legumes, you leave the root in there because that nitrogen will still be on those nodules. But anything else you can pull out.
Okay.
As long as you don't waste it, you know, there's a thing in permaculture which is produce no waste. So as long as you're not just going to throw it away, if you're going to compost that root, it's only going to go back into your soil anyway. You know, so it's about creating that cycle. You can still leave it in there, but I would say if you're going to take the tomatoes out, you might as well leave room for other roots to get in there. You know, so it's a lot of it is about timing. They call it succession, as if you're growing, you might grow tomatoes up until a certain time. Once you've harvested those, you want to get something else planted in there as soon as you can.
Okay.
Yeah.
Okay, thank you.
Oh. And your other question about the ink from the newspaper.
Yeah.
So I did a bit of research. It appears that most newspapers now use soybean oil for the ink.
Okay.
There are chemicals. I can send you the article I was looking at. There are chemicals that are used, but per this article, none of them are toxic to human health.
Okay, that's good to hear.
But avoid glossy paper, essentially.
Yeah.
So if it's just normal paper, I think you should be all right. I also looked into craft paper, which is like that brown paper, you know, that you get with like when you get stuff delivered. Because I was using that as well. But it seems that that's actually probably more toxic. It seems to have more chemicals.
Oh, okay.
So
Okay.
I would say,
I
I mean, if I find anything else, I'll let you know.
Yeah, thank you. I'm just going to stick with the newspaper.
Okay, cool.
Thank you very much.
No worries.
John.
Excellent.
Can
Cool.
I ask one question, John?
Yeah, go for it, Robert.
To build on what Pauline says, I've got an allotment plots, and just to use tomatoes as an example, if I've got 20 tomato plants and I plant 4 different varieties, what I was going to do was put basil and onions in between them. And let's say with courgettes and squash, just dot things in between them. But what it means is there's a lot of bare soil. And what we do on the plots where I am is, I mean, I'm clearing the soil now, so it goes completely against what you said, right? Which is fine. It's all about learning.
Hmm.
But all I can probably do now is just get lots of organic mulch or something to put on that bare soil, given that I've cleared it.
Yeah, sure.
Grow into the gaps, and then next season, come October, whatever, then I go for cover crops and try it a different way next year. Does that make sense?
Yeah, yeah, sure. Even if the soil is covered with mulch, that's cool, because it's going to prevent erosion.
Okay.
It's going to prevent like extreme swings in temperature.
Yeah.
And also if you're covering it with like hay, for instance, you're adding carbon, so it's only going to help, you know.
Okay. So hay first, mulch on top. I mean, pack down the hay. Would that work? Like a mini kind of compost system?
Yeah,
Just too
yeah.
close?
You can do several layers of whatever you want. It's I would just be careful in regards to if you add too much nitrogenous material, so too much green material, you can then swing your pH a bit too high. So the thing with nitrogen is it can go two ways. Nitrogen, when plants convert nitrogen from the air, they can convert it into ammonium or nitrate. So weeds love nitrate, yeah, and ammonium is good. So when you go above pH 7, this is why I talk about the pH testing. When you go above pH 7, nitrates thrive. Weeds thrive on nitrates. So if you add more carbon and more woody stuff, you're actually going to, it may take some time, it may take a season, but you will gradually bring that pH down. And that ideal zone is between 6.5 and 7. So what I did when I first started mulching was I tested my soil before I started mulching, and then I tested it the season after. And it went down by about 0.2, 0.3 on average. So mulching does work. As long as you've got that carbon-rich material on there, it will bring it down. And there are other things that you can use to bring the pH down. You can use things like seaweed, soluble seaweed, liquid seaweed. That helps to bring it down as well. But yeah, it's, you know, you do something and then, you know, you learn from it. But the great thing about permaculture is there's always a solution. Even if you make quite a big mistake, it's always recoverable. You know, it might take a bit more time, but yeah, man. So that's cool. Yeah, just do that, and that should work fine. No worries. Cool.
John,
Yeah.
nice. Can you hear me?
Yeah,
No.
I can. How you doing, Frost?
Okay. Okay, thanks. You mentioned earlier that fruit trees prefer acidic soils. Is that most fruit trees?
Yeah, yeah. There's always caveats to it, but yeah, most fruit trees will require it does range from tree to tree, but you're probably looking at between like 6.5 and 6.8, something like that. But if you're growing something like blueberries, they require like 5.5 to 6.
Yeah.
Yeah.
I've planted a few new trees, and I'm wondering if I ought to try and put acidic stuff there, things like green gages and
Have you tested your soil? Like done a pH test on it?
No.
I would test your soil before you remediate. Look, it took me about a year. I'm not a process driven person. I just like to do stuff and see what happens, you know. But it does really help to test, because it saves you a lot of work. It saves you a lot of like having to backtrack on things, you know. So you can buy these really simple pH testers, you know.
But then you've got to know what to do when you found the result, and how do you make it more acidic, and how do you make it more alkaline. So then you've got to put that into practice too.
Yeah, sure. And that
But
will be
I
that'll be my
also-
next webinar.
Yeah, it's. I also heard that there's some biochar that's particularly good for trees. So I'm wondering about if you can just put that on the topsoil, or whether you have to put it with the roots.
Okay, so biochar holds more water.
Yeah.
And it's obviously a place for microbes, which are really important. I'm not sure of its, its context towards trees. I haven't heard that specifically.
Yeah.
I can do some research into it.
I think this particular company do one that is aimed at trees.
Okay.
They do. So. But I think I'm trying to work out if it's okay if I just put it on topsoil, or whether it has to go in when they're put in.
Okay, so trees need a relationship with mycorrhizal fungi. They need a relationship with our vascular mycorrhizal fungi. So that it may be that they've charged this biochar with fungi. That may be why. Obviously, you always want to go for the root. You always want to go near the root. So I would say, if you're going to get it, put it near the drip line of the tree, which is where the roots will end. Or have the feeder roots there. That's where they'll probably absorb it the most.
So is the drip line near the trunk?
No, the drip line is basically the ends of the branches.
All right.
Where the water drips off the trees. That's really
okay.
There's always caveats to this, but that's where most of the roots will kind of end. That tends to be the case.
Okay.
The other thing you want to be careful of is, if you're thinking of like adding wood chips, fruit trees get inhibited by softwood. So this is for anyone else as well. If you're ever going to add wood chips around a tree, make sure it's hardwood. There's a guy called Michael Phillips. He's passed away now, but this guy, he was like an amazing orchardist. And you can find him on YouTube. But I would say, have you seen like reviews? What's the company called? Do you know?
Carbon Gold.
Carbon Gold.
It's, yeah. Have you heard of Craig Sands? He started up something like Green and Blacks. He was one of the founder members of that.
Right.
And he's very into organic stuff, because he did Whole Foods or something like that.
Right.
He started that up as well, and he's getting into the soil now.
Yeah.
That's his
Everyone's jumping on the bandwagon.
project. Well, no, he's been doing it since 2007 or something.
What, with the soil?
So he started the company up then.
Okay, cool.
Yeah.
Yeah, brilliant. I'll check it out, actually. Yeah.
Yeah.
I would, yeah. I mean,
I'm going to get on the tree, and I'm debating whether to put some of this tree stuff in the soil, because I put some that bacteria that you mentioned.
Rhizobacteria.
The roots. Yeah.
Cool.
So,
yeah, but I mean,
want my trees to do
some
well.
research for you if you want, and look into it. I'm quite interested myself, actually.
Yeah.
Yeah. Okay. Cool.
So it's supposed to be amazing for plants. Biochar.
Yeah, biochar is amazing. It is. It's a great thing. It's, I mean, yeah, if he's produced these companies, then he obviously has a lot of experience. So I'm sure he's done his research.
Yeah.
But yeah, maybe I doubt it will inhibit it, you know. So I think it's worth giving it a go. Because if it does work, you can
Yeah,
share it
yeah.
with other people, can't you?
Yeah.
Yeah.
Well, it's my experiment this year.
Yeah, brilliant. Nice one. I look forward to seeing it for us.
Another quick question. Yes. Well, hopefully in the summer I'll have all these fruit trees.
Yeah, brilliant.
But and another quick question. Do you look at the moon planting at all?
Yep.
You know, planting depending on where the moon, what sign the moon is in. Because I've been looking at that, but there are 2 different calendars that you can use, and I'm not sure. They obviously come with different days for planting the same thing. So I'm not sure which one to use. This is the one I've got on me at the moment, but I don't know. It comes like this.
Okay.
There, you can see it.
Yeah.
And it
yeah.
do ideas for each.
So does that talk about? It obviously talks about the waning and the waxing of the moon. Does it say?
Yes, it does. It also talks.
Yeah, go on.
It also talks about the sign that the moon is in as well.
Okay.
So,
right.
I mean, I can understand the sign side, but I'm not sure about the waxing and the waning.
Well, because the waxing and the waning. So, the waxing and waning is basically how the moon affects the water table. So whether the water's being pulled down or it's being pulled up, that will determine whether you're planting a vegetable that grows above ground or below ground. Does that make sense?
All right.
Yeah.
Yeah.
So because what you want is you want the gravity of the moon to affect the part of the plant that you need to affect. So if you've got a plant growing above, the seed will germinate first of all, and then the roots will go down. With a root vegetable, you're looking at it the other way. That's what I haven't looked that much into moon planting, but that's my understanding of it. Yeah. But in regards to those 2 calendars, I'm not sure what that means. I don't know if anyone else knows about that, but
it probably means one of them is wrong, right?
Yeah, exactly.
I was looking at this I was looking at this a few weeks ago for us, and I went down to the Rudolf Steiner place in London, and there we actually made a preparation. They used the Maria Thun, THUN calendar.
Oh yes, yeah, I've heard of it.
I didn't know there were different versions. That becomes interesting. But I started following this cycle of roots, leaf, flower, and fruit. I plan to sow based on this, and then transplant them, and even tend the soil around them as well, just to see what happens, and get some biodynamic preparations as well.
So are you planting the seeds on that right day, or are you transplanting them as well on the right day?
Both. I'll work, it's probably outside this topic for now, but I'll work on the root crop on the days that the lunar calendar says, whether it's to sow, transplant, even prune. I'm going to try and follow that this year and see what happens, because it seems to be quite successful. However, obviously what John's doing as well is successful, and the 2 probably somehow will complement each other, I hope.
They'll work together, won't they?
I hope.
And I think the interesting thing, I think the interesting thing is it's a little bit of everything. What I'm learning continually is there's no one right way to do things. And I think this is what's got us into this mess, is we just go one route, and there's like, it's remediating soil. There's so many different ways to do it, and it's all contextual, And we can use biodynamic farming, we can use permaculture, we can use, you know, things like terra preta. They're all really important. And depending on what your situation is and what your circumstances are and where you're growing, each one's going to give you a little bit of help. So I think it's really important to just to remember that.
I've got another question, but I'll let everyone else chip in first before I ask my last question.
Yeah, sure.
So everyone else gets it.
Does anyone else want to ask a question? Doesn't seem like it. Robert, go for it, mate.
So look, it's a topic for another day, John.
Okay.
So I'm just going to throw this in and then ask my question because it goes back to testing soil. I think I'm starting to understand now why copper tools become beneficial rather than using steel or other types, because again, they're not changing the electrical charge of the soil. So there's a big thing with certain people that I'm talking to about buying copper to use as our trowels and even our spades, but even now you're saying maybe don't use a spade too much. But it's all about these negatively charged ions that become beneficial for plant life and even for ourselves. So this lot all starts to link together as far as I'm concerned. So the starting point for me has to be to test my soil. And on the plot, I've got kind of 4 main beds, and then I've got the fruit bushes. So if you could send out somehow via email, I'll say it now, which soil testing kits would you go to buy for a novice to start testing their soil?
Okay, so yeah, I mean, so really to test, so the home testing kits that you get, the extent of those are only going to tell you your pH, your nitrogen, potassium, and phosphate. That's the limit, as far as I'm aware. If you want to know about any other of the elements in the soil, you need to go to a lab. But they're not actually that expensive. You're probably about 60 quid.
Yeah, but to be honest, John, if I start going down a road, if I have too many variables, my head will explode, right?
Yeah,
so,
sure. So
yeah,
start
I was
with
going
that.
to use country.
Yeah. So I
was
use
going to use country tea. That's what I use. But go on. So what's the home test kit? I
used one called Rapitest. So it's RAPITEST. It's not going to be. It's like you have like a powdered solution. You stick your soil in a little test tube, you stick the powder in, and then you stick the water in, you shake it up, you put it in this little machine, you press the button, and it will, with your pH, it will give you, I think it's from 5 to 8, which is the normal kind of, variable. And then with your nitrogen, your potassium, and your phosphate, it will tell you whether it's depleted, whether you've got enough, or whether it's in excess. It's good because it gives you a starting point. So I found that quite beneficial. You can get cheaper ones, which are just like little containers. It's the same principle, but you just haven't got the electronic readout of it. If you want to, so that's probably the best overall one. You can buy non-electronic pH testers, which I've got, and you just have a cathode and anode you stick into the soil, and it will give you an average pH of that soil. But they're not going to be that exact, so, but they'll give you an indication.
What I'll do, because I see me starting this with baby steps, and I can already grow things. So this is kind of adding to it. So to use the rapid test will be the first thing.
Yeah.
And then applying mulch to cover the soil will be the second. And then whatever you can conjure up, if I can come to the other sessions, which I intend to.
Yeah, sure.
I'll just put it on it that way. I won't try and agree to grab it all in one go, because that for me doesn't always work that well.
Yeah, cool. No, I get it. I get it.
No, thank you,
Excellent.
John. Appreciate it.
Thanks, Robert. Cheers. Cool. Yeah, I mean, any other questions? If you think of anything later, feel free to email me. And also, if you've got any suggestions about what you might want me to cover in future webinars, I'm more than happy to consider it. And if I can fit it into my plan, we can do that as well. And I just, I want you to know that I'm literally always learning. Like, it's a constant educational experience for me. I don't know everything, but I feel that I'm connected to a network of people that I'm learning from, who are at the, they're at the heights of permaculture, soil biology. And I feel like really grateful for being able to just pass on this knowledge to other people, and I think it's great, building a network of people that want to grow food and want to create a community is really important. And because it's not just about growing food, is it? It's actually about sharing your successes and your failures as well. They're really important, right? David Holmgren, who's one of the permaculture founders, he made a massive mistake and basically locked up loads of calcium in his soil, which this was like 5 years ago, and he's still trying to sort the problem out.
Mhm.
You right? And it's really important, because he didn't know what he was doing at that point. Now they've found out how he did that, so even people that are really experienced can make like massive mistakes. So that's another thing. Don't be afraid of making mistakes, because that's how we learn. That's how we actually grow the most. So cool. So if there's no more questions, we might as well call it a night. Thanks everyone very much for joining.
Thanks, John.
No worries. And as I said, send me any questions if you want, any suggestions, and we will, the next one I plan to be on the 10th of April, which is 4 weeks. So look forward to seeing you then.
Thank you. Yeah.
Thanks very
John.
much.
Thank
All
you.
right, cool. See you later, guys.
Bye.
Bye-bye.